Good afternoon, all. So, hope my screen is visible and I'm audible as well. Am I?
Yes, sir.
Yeah, thank you. Thank you so much. Right. So, today's session, so where we could talk about overview of software platforms and the development for this mobile application development. Okay, or the portable device development. So the content for today's session, we're going to talk about the overview of these platforms where we build those applications, and particularly to build application for these portable devices, we require some operating system, so a support of it. So which we tell them as the mobile operating system. So what it is and the architecture of that, and the framework for different mobile platforms, so the architecture behind them, and the development platforms and development tools which is used in order to build those applications to make use of those devices. Different programming languages supported for those applications to be built, where to ensure that the correctness of the application. So before we deploy, so we have to ensure that they are working properly. So that can be simulated through those hardware devices. So or it could be a software based simulator or a hardware based emulator. Okay. So and then we're going to talk about the software development kit and development environments. So ultimately, the life cycle of applications also we're going to talk about. Okay. So just to recall from the previous session, right? So what we discussed is this, right? So we spoke about the hardware platforms, which are set to be portable devices. What those portable devices are. Okay, so which has any hardware platform, the device you take to have uh, to achieve something out of that as a portable device. So which should be able to process something. So which has a processor, which has a set of memories, or will be memories will also be exist with for them, and some external devices which will be connected to that, and so different sensor, the power, and the IO. So example, Raspberry Pi, right? So one of them which we discussed or which you've seen on that in the previous session, we just saw that it has the processor which has IO connections for various devices to be connected, and the different sensors with an application of the agriculture, right? So where we spoke about the different sensors over there and other things, right? And the different measuring platform, the parameters for those devices or the platforms, right? So we also discussed with respect to the performance, the efficiency of the battery matters to them because they are like portable. So when we talk about portable, the device has to be carried along, right? So, but they have to work on. So in order to work, it requires some uh, battery, right? The power supply. So the power supply is given through the battery, right? And ultimately, a portable device cannot be large enough to carry. So, right, it should be a portable, so it should be small in size and the capacity and this weight also. Ultimately, you should be able to connect, right? Because in have to have a communication. So to get the work done from that, it has to communicate to the various devices. So that connectivity should also matter. Right? So these things all we discussed in the previous session. Different hardware platforms we spoke about the mobile phones and how these mobile phones are getting connected to the wireless medium, right? So mobile phone platform view, and wherein that system on chip, right? So where the processing ability will be defined, and then the modem, so where required for you to convert your analog to the digital to the where the signal can be modulated and demodulated, right? So that the RF front end, so antenna, sensors, UI, and power management. So wireless stack, which will be focused, where you're going to talk about the different cellular connectivities, 2D, 2G, 3G, 4G, 5G, and things like and other things. We discuss about the Wi-Fi, Wi-Fi wireless fidelity, where how these devices get connected to them, and the Bluetooth, which is restricted to a smaller distance communication. Right. So these are all things what we have discussed in the previous session. So the impact areas for this wireless medium also we discussed. Right. So and then we spoke about something related to IoT and the wireless. So with the sensor node, connectivity, processing, the cloud and the edge integration, common IoT building blocks, right? So different connectivity modules on those devices and the power unit interfaces, right? So all these things we discussed, and wireless options for IoT, which is through Wi-Fi mode, or it could be through Bluetooth, right? Or even the cellular network also can be used here in order to get connected. So then we had an example to illustrate this concept, right? For other, this is what we call as IoT. So with the Raspberry Pi, right? So where we spoke about different versions of Raspberry Pi and a different application which has been demonstrated through that, which is the smart agriculture to have the sensors which has been deployed to sense the data to soil moisture and the temperature and other things, right? So which will have a CPU, will have a general purpose IO USB network and the storage. Different sensors like where we talk about motion, location, environment, health, proximity, camera, generic hardware platforms. So where you're going to talk about reusable base hardware plus a modular interfaces plus software defined functionality. Right. So these are the record lectures supposed to be uh, uh, understood by you, and you have to go through that. So where you're going to talk about mobile platforms uh, from a historic perspective, how it has been evolved, right? Mobile different platforms and on-rail architecture, when which you want to talk about. So now let us delve into the core concept of today's session. So where we talk about software platforms and the development. It's any typical development platform, right? So which requires certain facilities, right? So one of them is very crucial thing is the kit, that is software development kit. So which is that's an environment where it has been enabled for you to build your code. So then ultimately when you build, it has to be verified for the mistakes, right? So which is a debugging facility. And then it has to be integrated with various other devices. So all the development environments. So we require integrated development environment to ensure that this is working properly. So we need to verify before deployment. So with the help of various the platforms which are set to be the simulators, or it could be a hardware-based emulator. So and then we need to understand about deploying this application onto a target device, which is on hardware, where we need to talk about her target hardware and related tools on that. And then ultimately it has to be documented. So with the concept. What are the programming languages does it support in order to build those applications or any portable devices? So there's so many languages are there. You can write them using the very fundamental, the basic language, which could be C. That is basically Objective C uh, or JavaScript, Kotlin, right? So the newly evolved for platforms, the mobile application platforms using a Kotlin, C++, C hash, Python, PHP, Swift, right? Java, HTML, Ruby, Rust, and Lua, Action scripts, SQL, so Dart, and these are all the programming languages which has been supported to build those applications using those environments. So these application programming languages, when you wanted to ensure that this has to be deployed onto a target device, so where that should run. Okay, so it's an example, Firefox operating system. So on this, if it is to be done, on you need to build this application using HTML and CSS and the JavaScript. So it will be usually when you're building them, so it has a standard-based development, and the concepts are very simple to understand. Go ahead with a structure where you define, and then how does it look like. So it will be simple to develop, and then which will go to concept will continues today with various web application developments, right? So which and then Ubuntu Touch, where you can use a QML or a Qt language, so supported by Qt framework and APIs, where it has a very robust and strong UI capabilities are available for them. and still used in limited applications, but not very wide. Okay, so used in select or community or embedded use cases only, but not for the mainstream applications on the mobile phone. Right now, if not, so we have another operating system or a platform which is mobile phones on that mobile phone with the help of a Android operating system, which is more prominently more competitive for that is on iOS. It is the two different, very widely used application operating systems or the frameworks which are available for building the applications is only two. Either it is Android or it is iOS. There are so many, like which you said, Firefox OS or Fire OS. So these are all things what exist, and there's something Samsung had its own operating system called as Bada OS, right? And Nokia went through to how the Windows itself for them. So, but they're all failed in order to sustain in the market and to have more user-friendly environment. So, which still now widely used and adoptable the platform is Android. Okay, so where the language can be used using a Java or it could be Kotlin primary. So where it could be used very more popular and wide varieties of devices are using them except Apple. So if you take any other operating, say any mobile phones which are there, so they all use those the Android as an operating system. I have a simple question. So before I proceed, can anybody tell me, or have you come across or used any other operating system in your mobile phone? I need the answers. Okay, so could you please mention? So don't force me to call the names. Okay. Siddharth Rai, when I call somebody, if the people doesn't respond, so I'll ask the Wipro team to mark you absent for the class. Shall we do that? Hmm? Ashish Rahul. Okay, fine. I'll have another way to ask this question. Can you people please raise your hands? Can you people please raise your hands? How many of your mobile devices are running with Android? Can you please raise your hand? Yeah, only two. We have, I think, the total strength of the class is around 75 or 6. Only 6 people say that they are running with around OS, so which Android. Only 6. Only 6 people are listening to the class. Shall I assume like this? How many of your mobile devices are running with Android? Raise your hands. So Ramya says Android, and then Vrunda, Surabhi, Surender, Shivam, Joydeep, uh, Raju, Malik, Angur Ravali. Okay, so totally 9 people. All right. Okay. Right. So let's. Thank you. Thank you. At least some of you responded. Thank you so much. So now I have another question. How many of your mobile devices are running with iOS? Please raise your hands. Those phones which are running with iOS. No one. So, except this 9 people, nobody is listening to the class. So that it says only these are listening to the class and they're just telling that nobody has iOS. Is that Jagannath Malik again? No, you said Android, right? Streaker. So you're running with a iOS reader, Streaker? Okay, fine. By chance, is there anyone in the entire class having a mobile phone which is running with a different operating system other than Android or iOS? By any chance, or by anybody, anyone you have, please. All right, so shall I assume no one? Fine. Okay. Firefox OS is discontinued, but right now only Android is running. The runtime on Kotlin is the preferred language for that. So, but it's just not only Kotlin, so Java is very much supported for that. So then, what is a mobile operating system? So it's a operating system, so which is will be used to run on the smartphones, the tablets, or the wearable devices, or any other a portable entity, right? So which has processing ability and that. So the modern mobile operating system, like which has been could run on even a laptop and a desktop, which can also run on a mobile devices right now. Features of personal computer operating system plus, which includes some additional features such as cellular network, touchscreen ability, Bluetooth connectivity, and getting connected to the wireless Wi-Fi, uh, which is going to connect to through say, the GPS, which also comes with features of audio, video, speech, right? So many such inputs through which we can process it, where it can also get attached with the various the entities such as sensors or the biometrics. And then you have NFC, so need for connectivity, security and privacy controls, battery optimization, ultimately AI-enabled features on device intelligence. So comparison when we talk about the earlier and today's generation. So current software platforms which has Android, iOS, where still exists. One of them is Harmony OS, as that's what I just asked, is there anyone? But we may not have, but still it is there. Independent ecosystem. So where next is not an Android app based. Okay, so Tizen, so mainly for a smart TVs which has been running, or maybe household alliances, appliances, embedded devices, right? So where then you have something called a Sailfish OS, uh, very limited number of devices which is using that and running that application or that OS. Ubuntu Touch OS has been used where it is purely on a community driven. Okay, and then the last one is KaiOS feature phone platform. So where it is very said to be very basic, all very limited uh, now due to reduced the application support like WhatsApp and many things. What are the different discarded or discontinued operating systems which was existing but today they are not? Okay, so one of them is Windows Phone came for a very short while and then they vanished because they could not able to sustain for those devices with the requirement for those things were not able to match with those devices. Firefox OS or Fire OS, which was being built and used by the Amazon Fire OS. If I'm not wrong. Okay, but still that is being used in the Kindle. That the Kindle is there from a Amazon where it's giving you to read the books, right? So that is running on the operating system, uh, which are a platform which is the Fire OS. Okay, so which is running for those devices. Then you have the BlackBerry OS for BlackBerry phones. Then Symbian was there. Windows mobile phones were introduced. Palm OS, Web OS, which is mobile is discontinued, but whereas for a TVS it is still existing. So then it has Mimo and Migo and Limo, such as those platforms which exist earlier, but right now they don't exist anymore, right? the Let us just get into the architecture of these things, right? So where gives you a little more information on those the operating system. So as we discussed, one of the old language which is used for mobile was like Firefox OS, right? It's a Mozilla based platform, open source. They're purely a standard based open web application which can fit into various devices such as Alcatel, OneTouch Fire, Intex Cloud FX, and then Spice Fire One. So which has different layers here, where it has the infrastructure layer, and then the open web platform interfaces, and above that you will be having a layer of building the application, which is application layer. The infrastructure layer, what it has, right? So it has a kernel at the base where it has to run those instructions or things like which requires a Linux kernel, and then a different the drivers which has been enabled for uh, to help. Hmm, okay, these drivers will be helping in allowing the predefined applications, the predefined libraries to be used, right? And then there are some modern firmwares were available which is going to boot those devices, things like. Okay, so what are the different open source libraries were there in the infrastructure layer? Is that It has supporting for camera, it has a Wi-Fi, it has a USB, it has a vibrator, the Bluetooth, many things, GPS, and all the things, right? So this is at the bottom layer. So above that, we'll be having a platform where it's going to give you to get connected to various applications or features of the software with the help of security for each of them to be enabled. Let's go to run on the Firefox browser. And the top layer is an application layer where it's going to give you a defined certified applications, and you have the ability to build your own applications with the help of those parameters. Then we have Tizen. It's been hosted by Linux Foundation. Its main components are like the kernel, the Linux kernel, and allowing to build your application through the WebKit runtime libraries. And this Tizen OS devices, which is going to run on very smartphones, tablets, in-vehicle devices, and smart TVs. Excuse me. ನಮಸ್ಕಾರಂ 16th ನೋಡ್ಬೇಕು ಏಕೆ let me see madam, not sure ಒಂದ್ ನಿಮಿಷ ರೀ ಓ ಇದೆ ಹೌದಾ ಓಕೆ ಸೊ ವಿಲ್ ಸ್ವಾಪ್ ಇಟ್ 17th ಆಗ್ತೀನಿ ವಿವೇಕ್ ಫಸ್ಟ್ ಡೇ ಆಗ್ತೀನಿ ಬಿಡಿ ಓಕೆ 16th ರೈಟ್ 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 ಅಣ್ಣ ಫಿಸಿಕಲ್ ಆಗ ಓಕೆ ಹಿಂಗಿತ್ತು ಸೂಪರ್ ಹ್ಮ್ 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 ಓಕೆ ಹ್ಮ್ 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 ಓಕೆ ಓಕೆ ಹ್ಮ್ 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 ಓಕೆ ಅಯ್ಯೋ ಗುಡ್ ಕಂಗ್ರ್ಯಾಚುಲೇಷನ್ಸ್ ಕ್ಲಿಯರಿಂಗ್ ಫಸ್ಟ್ ರೌಂಡ್ ಆಗುತ್ತೆ ಹ್ಮ್ ಓಕೆ 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 ಅಲ್ಲಿ ಅದೇ ಟೆಕ್ನಿಕಲ್ 2 ರೌಂಡ್ ಮಿಕ್ಕಿದೆಲ್ಲ ಪ್ರಿನ್ಸಿಪಲ್ HR ಹಾ ಇದೇ ತರನೇ ಡೆಮೋ ಇರ್ತದೆ ಒಂದು ಇನ್ ಹೌಸ್ ಮತ್ತೆ ಇನ್ನೊಬ್ರು ಆಮೇಲೆ ಎಕ್ಸ್ಪರ್ಟ್ ನ ಕರೆಸ್ತಾರೆ ಜೊತೆ ಬಟ್ ಫ್ರೆಶರ್ಗೆ ಅಂತ ಅದು ಪ್ರಾಬ್ಲಮ್ ಇರಲ್ಲ ಮೇಡಮ್ ಫ್ರೆಶರ್ಗೆ ಅಂತ ಅಷ್ಟೊಂದು ಇದು ಮಾಡಕ್ ಹೋಗಲ್ಲ ಹಾ ಮಾಮೂಲಿ ಒಂದು ಯಾವ ಸೀನಿಯರ್ ಫ್ಯಾಕಲ್ಟೀಸ್ ಕೂತ್ಕೊಂಡು ಡೆಮೋ ತಗೊಂಡ್ತಾರೆ ಹೌದು ಹೌದು. ರೈಟ್. ಸರಿ, ಆಯ್ತು, ನಾನು ಕಾಲ್ ಮಾಡ್ತೀನಿ ಆಮೇಲೆ ಒಂದು ಕ್ಲಾಸ್ ಮಾಡ್ತಾ ಇದ್ದು. ಓಕೆ, ರೈಟ್ ರೈಟ್. Sorry. So Tyson was where it was running. So majority of them were like smartphones, the tablets, uh, the vehicle radar communication, or smart TVs. Okay, so which has a core which is running with various libraries, and then all those core libraries were running on the Linux kernel. Okay, and the different device drivers. So there where it has a framework for application, graphics and user interface, multimedia, connectivity, and web applications and security. So then you'll have a framework for building those applications where it can have built-in applications and a web-based application framework which is supporting you to build those applications. So Ubuntu Touch, which is Canonical Limited, so where it is an open source, so where it is uses a Qt5 based Touch UI interface, and it was built, which was run majorly on the PCs and then phone, PC in your pocket. So that is what the meaning of that, right? So just to understand that, there's one small link is given. Let's play that, and we have to have.
Ubuntu think that perfect world should be a reality. That's why they took your phone that's as powerful as a PC and decided to put a PC right inside of it. Shazam! Ubuntu for Android is born. It's not literally magic, but it's kind of close. Your quad-core handset is a phone when it's unplugged, but when you connect it to a monitor and keyboard, boom, you've got yourself a full Ubuntu-powered computer. Picture this, you're working on a spreadsheet or writing an email at work, but it's quitting time, so you unplug and can take it on the go. No syncing voodoo is required, since the phone is the PC. And it's not all boring work stuff either. You can use the desktop to browse your photos, videos, for music, email, to utilize many browsing tabs, to sync your address book, any part of your digital life. And since your PC is a phone, you can make calls or send SMS from the Ubuntu desktop. And hey, it's Ubuntu, so you know it's going to be fast, fresh, and virus-free. Not to mention the thousands of desktop apps available to run on your phone. All of a sudden, that double life becomes a single life, and your awesome phone just got more awesome. There's no reason to lead a double life anymore. So get a phone with Ubuntu for Android and start living a life less complicated.
What if
Wonderful,
your
right?
computer could be in two states at once? Meet the qubit, the building block of quantum computing, unlike a regular bit, which is either 0 or 1.
Right. So our choice for building the application, which is wide variety of users and the community is using, which is Android. So which is it's an open philosophy, which is very much easy to customize according to our needs, modify and fix anything in your user interface or even any applications which has been built, modify to suit your need as you want, right? So with a user interface, how you need to be appearing to you on the screen, and how do you feel when you're using it, right? So that's a great example platform to adopt and learn. So all source code which is available, development tools and environments are available. Popularity of the platform provides open information and community to discuss. There are devices are available to easily test it, right, or experiment them, right, explore and play around. So this the platform architecture, if you look at that, so it's purely running on the Linux kernel. Okay, so which has the various drivers which has been already been used with audio, binder, display, keypad, Bluetooth, camera, USB, Wi-Fi, many of them. So above that, we will be having the hardware abstraction layer. So with audio, the Bluetooth, camera, and various sensors. So above that, you'll be having a native C or C++ libraries, which is going to give you to build your applications, right? To the flexibility of choosing them and just running them, and ensure that they can be easily get into runtime. Okay, so which has a WebKit, OpenMax, the libc is there, media framework, and OpenGL for graphics, right? And it has the runtime. Okay, so which has the ART Android runtime which is available. So earlier they were using uh, uh, Java Virtual Machine for those runtime. So but right now instead of that they're using ART, and then the core libraries which exist. So the above that it has a application programming interface framework for available with for the Java, where it is going to the entire Android has four components in it. Okay, so the four components are like content provider, intents, and the broadcast receivers, and the what is that? Uh, intent, broadcast receivers, content providers, and one more. I'll will just come to that. Okay, so which is going to give you for managing the activity, so activity, intent, content provider, and the broadcast receivers. So these are the four components of the entire operating system, so that we enter application is built with this only these three things. So which has system applications which is default existing, so you can have your own application built. So it's an open source purely Linux based system, and there are so many devices and forms of factors which exist, right? So these are the major components of the Android platform. So what are the common features? It is an open ecosystem, so there is open standards, open tooling, so anybody can contribute to that, and if it will need to be validated. Only thing is that, but except that anyone who want to to contribute for the development and the betterment of that, they have the provision to do that. So supports multiple device types, where you can run that on a mobile phone, a smartphone, or a tablet, or a wearable devices, or a TV, and embedded devices. So it has giving you rich set of the development environments are available for you to build your application, and tooling support. So it has very the ecosystem which is very much supporting you to build, develop, test, and deployment through the software development kits. Native and cross-platform development supports are available. So where it's going to give you the supporting languages could be Kotlin, Java, and C++. Majority of them now they've been building the applications using Kotlin. So you have a UI and web-based the applications which could be built through which you can still run them on your web-based also with the help of HTML5, CSS, JavaScript, and limited use cases with a QML. So latest like Android development, so which is updated version which is presently, okay, 2020. So which has a APIs. Android SDKs will come with a set of APIs, libraries, build tools which are there. We'll be using the tool here, or a platform which is a Android Studio, so official IDE. So which earlier we were using Eclipse for building that, but today Android has its own studio. So we'll be using Android Studio here to build those applications. So there's an AVD manager, Android Virtual Device Manager, so that you can create that. With the help of when you create the device, it can be helpful for you to emulate that. And then you have the ADB, the debug bridge, which is available. Then it's going to give you integrated debugger as well as logcat for you to understand what is happening. So there'll be a layout inspector and the UI inspector, which has replaced when it compared to earlier, we had a hierarchy viewer, but nowadays you have nothing as such. It is would be easier. Lint and static analysis tools, profiler tools will be there, which is going to measure the usage of the CPU, memory, network, and the battery. So Gradle build system is there, which is going to build your applications with the help of all those things, and testing tools to ensure that this application is perfectly working, right? So which could be unit tests or UI tests and automation, or you will be having a Dalvik debug monitor, Eclipse, a Monkey runner, or legacy and low logger primary. So the mobile application development platform, a mobile application development platform is a software framework. Uh, excuse me. That allows businesses to rapidly build, test, and deploy mobile applications. So it's going to provide you a unified framework for designing, so coding, testing, and deploying, as well as preparing a documentation of those mobile applications. It also comes with an integrated set of tools for streamlined development. So, what are the features? Right, it supports the enormous set of native and as well as web as well as hybrid application development, so that it can run on a standalone devices or it can be on the web-based applications or anything as such, which is combination of both. It also have a application management, mobile application management tools, which is there as part of this application lifecycle management. Also comes with a cloud-based deployment and real-time collaboration tools also. It also comes with a cross-platform development, so which is an iOS, Android, or web. So using frameworks like Flutter and React Native, integrates with modern DevOps pipelines and CI/CD systems for continuous deployment. So native Android. So this comparison of different operating systems given, right? So which native Android, so purely Android supported, and languages used is Kotlin or Java, even C++ also. So it gives you a better performance, and rich set of devices are available to ensure that they can be tested and deployed. Native iOS, so it is purely iOS based and it could be built using Objective-C or a Swift language. So which has been only been running on the devices which is Apple ecosystem. Flutter, so where it's going to run on Android, iOS, WebOS as well as desktop also. Dart is a language that's been used, which is a single code base. Near native performance will be there. React Native, so which is going to run on Android as well as iOS, so which purely runs on with built using JavaScript or TypeScript, so which going to uses the native UI components. Xamarin, so .NET MUI, so which is going to run on Windows as well as Android as well as iOS. The application is built using C hash. So it's purely built for Microsoft ecosystem, and they've been used for enterprise use cases. Iconic capacitor, where Android and iOS are web-based, so HTML and CSS and JavaScript is used as a programming languages for them, right? So they've been used for web-based faster development. Progressive web applications, so it's been built using on the platforms called only for web as well as mobile browsers, so where it uses HTML, CSS, and JavaScript. No application store required, so limited hardware access will be there. Unity, which is going to run on Android, iOS, as well as AR, VR, where augmented reality or virtual reality. So they've been built using C hash, and they'll be used majorly for building applications such as games or simulations and other things. Harmony OS, where next, so which been built for UI devices. Arc UI or native APS, independent ecosystem, no Android APK support for that. The last one is KaiOS, which is future phones. Web technologies is a major platform. Limited applications. Definitely, it's a declining ecosystem. So cross-platform development. So the once you build an application, so that could be able to run on the multiple devices, right? Multiple platforms. Uh, Reduces redevelopment and efforts and porting issues. So we require something which could easily run. I need to write an application such a way that it could be able to run on both ways, such as like Android or it could be iOS. So that is what my objective should be. May not exploit the full feature of the underlying OS support and hence not always optimal it is. So good for small to mid-size applications, not tested for enterprise class applications. So glad for cross-platform tools. So Flutter, single code base, near native UI for Android and iOS. React Native, so JavaScript-based applications using native UI components. And .NET MEA UI, so C hash framework for Android, iOS, and Windows as well as Mac operating system. So Iconic plus Capacitor, web technologies packaged as mobile applications. Kotlin multi-platform, so shared business logic across the platforms, right? And Unity, so cross-platform game and AR/VR development. So databases where it is embedded on-device, the database will be used for building the application which requires to store and retrieve the structured data. So or anyway, so it is obviously any device which comes with will have a storage or of the system which is going to keep that as a safeguarding your data. So where the database is required or the file storage should be required. So embedded within the mobile applications, so file-based local storage will be there. So supports random access for fast read and write cycles and lightweight and optimized for mobile devices. So it also comes with a different database technologies which is being used with applications, so building. So such as SQLite, which is defaultly available in the Android, default local database for Android as well as iOS also. Room, so SQLite abstraction will be used. So modern Android database layer. One more is the objective based mobile database, which is Realm. Core, the couch-based Lite, so which is an offline first and sync-enabled a mobile database. MongoDB, so cloud-based mobile first database with the cloud synchronization. Oracle, the Mercury DB, so which Oracle been using, so which is having the embedded key and value database. Testing tools, which is used here in order to ensure that your application is working perfectly fine. So we'll be using an Appium, which is a cross-platform tool, which is to ensure your correctness from both perspective, as well Android as well as iOS. Espresso, which comes with Android, so native UI testing only for user interface to be verified from that. So UI Automator, so which is going to run on Android. So system level testing for a UI will be carried out. Execute test, so XCU UI test, so which is purely used for iOS and native UI testing. Detox, Flutter integration test, Selenium Playwright, as well as Firebase Test Lab. So these are all the testing tools which has been used. So don't when you are building so or developing an application. So you have to be careful, right? So don't design only for today. That means your application you are choosing, ensure that you're just not been built only for today. So it has to be thinking a way ahead, right? So what it could be, maybe tomorrow, day after tomorrow, or it could be month, or it could be year. So you have to think in the longer direction and then assume because the changes are inevitable anytime. Right. So it has to be there. It has to go with that legacy. So don't treat platform choices trivial. So it defines performance, reach as well as cost also. So don't ignore the system limits, such as your memory capacity, your battery usage, network, right? And don't assume all browsers, devices, or screens behave the same. So every browser, every system will have a different way of communication, different way of instruction set architecture. So all these things will matter a lot, right? So don't make the UX and afterthought, so that you have to have a very clear picture before you go for development of those applications. So clarity and simplicity, which is very much core feature, which is required here. Don't build applications that work only online. Okay, so it is offline first matters. Don't turn the application into a branding brochure, so where you can majorly concentrate on the users. Okay, so don't overload the users. So information should be given which is very limited, very clear, very crisp, and very easy to understand. So it should be digestible. Don't reinvent patterns so users already understand. So don't leave users guessing. So progress and feedback reduce the frustration. Don't break the flow. So handle the errors which occurs when clearly, gently, so that it cannot repeat again. Should not repeat again. So don't cram content into small space. So design for touch as well as things. So not for the mouse. Don't force typing when selection is easier. Don't skip real device testing. So emulators don't reveal everything. And don't ignore feedback channels. So applications evolve through the users. Okay. Now, simulator and emulator. So Android emulator. So it is an hardware based mimicking the. So it's something like you're going to mimic the entire hardware such a way that so that you can run your application on that emulator. You feel that it is running on the exact mobile phone. A virtual Android device that runs on your computer enables the development and testing of your application. So where without the help of your physical device. So you can set everything: the CPU capacity, your RAM capacity, everything you can do. Key capabilities of the applications can be clearly tested. Simulates the hardware features, including your CPU, memory, and sensors, as well as camera. You can run your application, debug the application, and then test it. So network simulation, Wi-Fi, mobile data, and speed, as well as latency, which also matters to ensure that they have been coping up with a real-time system. So it also comes with SMS and call simulation, location and GPS simulation, battery and power state simulation, so multiple device platforms, and screen sizes and Android versioning testing. Simulator is a virtual environment that simulates application behavior. So where it's not the real hardware. Okay. So where, for example, network simulator, where you need to build your entire network. So that's a simulation. Entirely, it's a software-based platform which has been enabled for you to ensure that the network is built and tested. So used mainly for the UI and interaction testing. So does not emulate the CPU here. So the memory consumption as well as the different sensors. The key characteristics of that is simulates the screen size, where it's going to say that the resolution and orientation of the device will also be available for you to test it. Touch and gestures behavior. So navigation of the user interface and the rendering of those layouts. The fast execution and lightweight, so suitable for early stage development and prototyping. So platform nodes, so where you have to, Android does not provide a true simulator. Please remember that. So we verify them, accuracy will be. The comparison between simulator and the emulator. So what it does, so it simulates the application behavior, where the emulator will hardware, it's only the entire hardware has been mimicked with the operating system. So hardware accuracy, so simulator doesn't have any hardware, but it is almost near exactly almost 100%, 99% it will be real world. The speed, it varies. Okay, simulator will be faster, but whereas emulator will be slow. Okay, so resource usage, simulator doesn't require much of them, but whereas simulator requires most of them. Like say it's running on your system, so that means it consumes your RAM, it consumes your CPU, everything. So sensors and the hardware in the simulator it may be mocked, but it will be real time, realistic simulation in the emulator. Use case UI and flow testing here can be tested in the simulator, but in the emulator, every feature of your application and system testing can be done. A platform supports commonly in iOS, which is being used, but the emulator uses in the Android. So iOS simulator, Android emulator, so AVD, Android virtual device, so which is so life cycle. So 5 stage of mobile application development life cycle. So it's going to start with analyzing, designing, develop, certify, and then deploy. So analyze the use case, technology, and the strategy for that, and then you're going to design the system with the help of user interface, wireframing, so POC as well as prototype. So then you're going to develop the performance and usability, security, and network response, the platforms, devices, and browsers. And then it's going to certify the application store certification and approval. And then they're going to have a deploy and maintain the application and device lifecycle management. So analysis where you're going to be your idea is conceptualized. So where you have to study and analyze the market, what works and what doesn't work in the system, and you have to know what are the similar applications exist and their data, and your idea of that. Identify the target consumers or customers who are going to use it when compared to others. Talk to potential customers to get their input and thoughts as well as their opinion for your concept. How will your application be paid for? Okay, so planning, uh, plan what features you'll offer in your the release, right? It's not that a single point of release or single one time release. It is like an incremental process where you're going to release through the features. Okay, so set the concrete and realistic goals along with the release plan. Identify resources to meet your deadlines. Budgeting for those costs. Right. So, and at the same time, so identify the resources to meet your deadlines, and then ultimately you have to plan your budget for those costs. So then you have to design. So design through the with the help of UI, wireframe, and things. Start developing a wireframe of your application. You can start to get concrete to feel of what application will be and how does it look like, and you have to plan your layout, right? Internet features of them. Pay attention to the user interface to make sure that it will feel natural on the devices that the application will be focused on. The tablets, smartphones, those different opportunities and constraints. Keep in touch with potential customers to get their continued feedback and revise your requirements as and when it is necessary. Okay, so this is how a wireframing. So prepare the 2D illustration, sketch the screen's interface, shows a simplified visual concept of the feature application, where it's going to tell you the functionalities, what are available, intended actions, relationships, and the navigation between the screens and other things. Okay, so 25% of the time it's going to be spent on this, you will be almost ready with your most of your work at the end. Okay, so what you design on the storyline, so that will be ultimately getting it be ready on your device. So these are different wireframing tools which can be used here: Figma, Sketch, Adobe, InVision app, Axure, uh, Balasmic, and UX Paint, Mock Plus, right? So all these are available, the tools which can be used in order to wireframe it. So backend can be designed so with the help of APIs, so which we use a RESTful API, Graph, QL, or gRPC. So from data flow diagrams and data modeling to structured database interactions, servers and cloud services with the help of AWS or Google or Azure for scalable the support of the backend. Servers and the cloud services, AWS, Google, and so databases, SQL, NoSQL, Firebase. Third-party APIs can be used in order to perform the data integration services. And maybe you can use the Firebase cloud messaging or OneSignal or AWS SNS for your push notification services. And the authentication can be done through authentication or Firebase authentication, AWS Cognito. So prototype, good time to develop a prototype. So which is an optional field, but still it will be always gives you a better feel of your application at the end. So allows the user to gain insights into what he expects from the application, works as a guideline for the application behavior and also the look and feel of it. Alternatively, wireframe diagram can be used to describe the application flow to the user. So once it is done, you're going to develop it. So select the right platform, tools, and widgets to streamline the development environment. Use the frameworks like Flutter, React Native, or Kotlin to enhance the productivity. And then the code, the application using the agile approach. So focus on one user story at a time. So building the time as well as building feature by feature, which is in the incremental map. So designers will create the application skin, so or the visual representation of the screens. These renderings are based on wireframes or represent the user interface that users will interact with. Developers will blind the functionality to these designs where they integrate the application logic with the available backend services using APIs, database, as well as server side. So testing, so agile process, the functional testing is continuous alongside the application build process and ensuring the quick iterations and immediate feedback. So testing involves integration testing, scalability testing, device drift, specific testing, and usability testing as well as automated testing also. For mobile applications, where we want to text additionally, so memory footprint or the leaks, is there any? How much memory is being consumed and efficiency of utilizing that memory. Load time, so minimize the loading times for Android, the application loading, the experience. Network utilizations ensure the application handles data efficiently and works well in different network conditions. So the security, so the test for data protection, encryption, and safe authentication. Device family or cross-platform compatibility ensure the application works across multiple device types with the help of like smartphones or tablets or foldables and many things. Last thing is certified. The application must be certified in order to be released in the Google Play Store or it could be Apple Play Store to ensure they are meeting the certain standards of those uh, OTA. So downloads as well as installation. So it is mandatory. So especially if the application includes in-app purchase or sensitive data handling, right? So the certification process involves compliance with the payment integration, data flow compliances, data storage checks, as well as security validation. So then you go to once it is done, you're going to deploy them. So you're going to use the application, relevant application repositories where it can be Google Play Store or Apple App Store, or it could be Microsoft Tools or a store. So where the managing marketing is crucial for successful launch. So use a better and affiliate advertisements and trial periods, so discounts and promotional schemes to attract the users. Prepare the SEO, the optimized website for the application to gather the customer feedback and reviews. provide support for users, including the frequency asked questions and troubleshooting. So offer multiple version uh, downloads for different platforms or device types. Leverages social media marketing, so email campaign and influencer collaborations to increase the application visibility. Maintenance, the last step of that, so we're going to bug fixes must be applied in the shortest possible time to ensure their retention. Use advanced debugging tools such as your Firebase Crashlytics or Sentry to track and fix the issues quickly. The risk users may drift to alternate applications if users issues are not resolved swiftly. So review behavior, so which is based on user feedback after every release cycle. So user feedback to add new features or improve uh, the uh, improvise your the intended plan and the application building. Okay. So you have to use the tools in order to get to know the feedback of them with the help of Google Analytics or Hotjar, or it could be application flow. You have to maintain a smooth update cycle with the help of giving prioritized only on one application at a time so that it can easily be concentrated, it can be addressed. So quick releases and updates keep users engaged and excited. So use continuous integration or continuous deployment to update our features. Billing, meeting, and others. So the robust mechanism should be established for managing your application usage and the need. So direct payments for application usage, which is there are certain applications which run only on the payment basis, otherwise they are not. So it depends on use integrated payment systems like Stripe or PayPal and Apple Pay. There could be a referrals also can be used here. Implement a referral program to incentivize the growth of the user usage or the number of users. Affiliate programs leverage the affiliate networks to expand user to reach and generate the revenue. Total versions of them, or it could be third period management. So where you can have trial versions of with clear automated conversion to paid plans after the trial period. Feature wise subscription charges. So provide the tiered subscription models with the charges based on the application features. So the process design the UI, add the event handlers, build and test on the emulator, and then generate the APK file. So then publish to the Play Store or download into a device using. So that's it from my end for today's session. So hope whatever I have discussed it is clear. So if you have anyone has any doubts or anything, please let me know. I'll answer your questions. Okay, so option that quiz, right? So okay, so here is the link for uh, the quiz, right? So request all of you to log in through your official mail ID and please take up the quiz and complete the quiz. Okay, I kindly request you, all of you, please take up the quiz that will fetch you the marks, right? So with this, we'll end the session here. We'll catch up in the next session. So till then, take care. Bye bye. Have a wonderful weekend. Thank you all.